The graph of sine x looks like this. And we can see the gradient of the tangents at certain points of the graph. For instance, when x equals pi by 2, the gradient of the tangent is 0. And it's also 0 at minus pi by 2 and at 3 pi by 2. At other points, the symmetry of the sine curve can help. So the gradient of the tangent at x equals 0 is positive, and it must be equal to the gradient of the tangent at x equals 2 pi. Also, the gradient of the tangent at x equals minus pi must be equal to the gradient of the tangent at x equals pi. They must also both have the same magnitude as the gradient at x equals 0, but be negative. Let's now plot the gradients of these tangents on a graph directly underneath the sine graph. Now, assume we can join up the points with a smooth curve. Whilst we don't know the values at the peaks and the troughs, what we've drawn looks remarkably like the graph of a cosine function. So now we've got an idea of what we're looking for, let's differentiate sine x from first principles. Now there's three things that we need to know. The first is our definition of our derivative. dy by dx equals the limit as delta x approaches 0 of f of x plus delta x minus f of x, all divided by delta x. The second is one of our trigonometric identities, and that's sine c minus sine d equals twice the cos of c plus d divided by 2 multiplied by the sine of c minus d divided by 2. And the third is the limit as theta approaches 0 that sine theta divided by theta equals 1. Now we can see this from a table of values. So if we have a look at theta when it's in radians, and then calculate sine theta, and then sine theta divided by theta, we can have a look and see what's happening. So our theta in radians, let's look at 1 first of all. The sine of 1 is 0.84147. So if we calculate sine theta divided by theta, we just get the same, 0.84147. Now let's make theta smaller. Let's go to 0.1. The sine of 0.1 is 0.09983 and so on. Just, it continued on there, sorry. Okay, if we do sine theta divided by theta, then we get 0.99833 and again continues on. Let's make theta even smaller now at 0.01. The sine of theta is going to be 0.00999 and so on. So sine theta divided by theta equals 0.99983 and so on. And you can see that as theta is getting smaller and smaller and tending to 0, then sine theta divided by theta is tending to 1. Okay, let's carry on with the calculation. So we have our y equals sine x. And let's start by just looking at the top part of our formula, our function of x plus delta x minus our function of x. Sine x is our function of x, so our function of x plus delta x is the sine of x plus delta x, minus our function of x, so minus sine x. And this is where we have our sine c take away our sine d. So we can rewrite this as twice the cos of c plus d divided by 2. So it's x plus delta x plus x divided by 2, multiplied by the sine of c minus d divided by 2. So it's x plus delta x minus x divided by 2. So this equals twice the cos x plus x is 2x plus delta x, all divided by 2, multiplied by the sine of x minus x is 0, so we just have delta x divided by 2. I'm just going to tidy this up a little bit further. So we've got 2 times the cos. 2 divided by 2 gives us just our x plus delta x over 2, multiplied by the sine of delta x over 2. So now, if we go back to dy by dx equals the limit as delta x approaches 0 of our f of x plus delta x minus f of x, which is this. So it's 2 cos x plus delta x over 2 multiplied by the sine of delta x over 2, all divided by delta x. Now, multiplying the numerator, the top part of the fraction, by 2 is exactly the same as dividing the denominator, the bottom part, by 2. So I'm going to rewrite this. The limit of delta x tends to 0. Taking this 2 from here and putting it as a division in the denominator. And I've done that so that you can see here we've got the sine of delta x over 2 divided by delta x over 2. And that was where our third fact came in, that when we had sine theta divided by theta, when we took the limit of delta x tending to 0, this will tend to 1. So let's actually take the limit now as delta x approaches 0. Sine delta x over 2 divided by delta x over 2 is 1. And delta x over 2 as delta x approaches 0 will be 0. So we're just left with our derivative of sine x being cos x. Let's have a look at the derivative now from first principles of cos x. The graph of cos x looks like this. Again, we can draw the tangents at certain points. And we can plot their values on a graph directly underneath the cosine graph. This time, if we join the points with a smooth curve, we get a graph that looks like minus sine x. Now, before we differentiate cos x from first principles, let's just have a look at the graph of the sine of x plus pi by 2. The graph of sine of x plus pi by 2 looks like this. It's just the graph of sine x with everything happening pi by 2 earlier. It's as though we'd shifted the sine curve back along the x-axis by pi by 2. And that just gives us cos x. The two functions are the same. Now, shifting the sine curve back along the axis doesn't affect the shape of the curve, so it doesn't affect the shape of its gradient function, only the position of the gradient function on the So the derivative of sine of x plus pi by 2 is the cos of x plus pi by 2. But the graph of cos of x plus pi by 2 is identical to the graph of minus sine x. So the derivative of cos x is minus sine x. Let's have a look at the calculation now. Y equals cos x, and we need to know three things again to help us do the calculation. The first is our definition of our derivative. dy by dx equals the limit as delta x approaches 0 of our function of x plus delta x minus our function of x divided by delta x. The second thing we need to know is one of the trigonometric identities, and that's cos c minus cos d equals minus 2 times the sine of c plus d divided by 2 multiplied by the sine of c minus d divided by 2. And the third thing is the limit as theta approaches 0 that sine theta divided by theta is equal to 1. So let's have a look at putting our function into this top part again. Our f of x plus delta x minus our function of x is equal to our cos of x plus delta x minus our function of x, which is cos x. So here we have our cos of c minus our cos of d. So let's do this substitution now. So it's minus twice the sine of c plus d over 2, so that's x plus delta x plus x, all divided by 2, multiplied by the sine of c minus d over 2, so that's x plus delta x minus x divided by 2, which equals minus 2 times the sine of x plus x is 2x plus delta x divided by 2, multiplied by the sine of x minus x is 0, so we're just left with delta x divided by 2. And again, as we did before, we'll write this as minus 2 sine 2x divided by 2 leaves us with x plus our delta x over 2, multiplied by our sine of delta x over 2. Now we're going to turn the page and put this into our formula so that we have dy by dx equals the limit as delta x approaches 0 of minus 2 sine of x plus delta x over 2 multiplied by sine delta x over 2, all divided by delta x. And that equals, and again we're going to do this change where instead of multiplying the numerator by 2, I'm going to divide the denominator by 2. So we have the limit as delta x approaches 0 of minus the sine of x plus delta x divided by 2 multiplied by the sine of delta x divided by 2, all divided by delta x divided by 2. Now, as we take the limit as delta x approaches 0, again here we've got the sine of delta x over 2 divided by delta x over 2, and we know that as delta x approaches 0, then this tends to 1. And then as delta x divided by 2 here tends to 0, then our derivative will be minus the sine of x. So our derivative of cos x is minus sine x.